Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk on heterocycles. Heterocyclic compounds play important role in our life. You also know 80% of drugs belongs to heterocyclic compounds. So knowledge of heterocycles is necessary for the human. You know how many of you can do without the morning cup of coffee? Every person need coffee in the morning. Why? You know, the coffee contains the heterocyclic compounds. Look at here, caffeine. The stimulating ingredient in coffee is the heterocycle caffeine. You also know 135 milligram of it in a normal serving. Of course, there is also a Roman espresso which has the 100 milligram of caffeine in less than ounce of the liquids. So my friends, now you understand the importance of heterocyclic compounds. You are taking every day 3 times, 4 times, some people taking 1 times this heterocyclic compounds, but we are not aware what we are taking, and that is the heterocyclic caffeine. A lot of other heterocyclic compounds from morning to evening you are associated with. So learning of heterocyclic compound is important for us. So what is heterocycles? Cyclic molecules that contains at least one heteroatoms, oxygen, nitrogen, sulfur. Oxycycloalkenes, oxygen containing heterocyclic compound. Azacycloalkene, nitrogen containing heterocyclic compound. Aza means nitrogen. Thiacycloalkenes means sulfur containing heterocyclic compound. Look at here. Oxirane, ethylene oxide. Same as you can see N-methyl aziridine, N-methyl azacyclopropane, 2-fluorothiacyclopropane, 2-fluorothiazine, oxacyclobutane, oxetane, 3-ethyl azacyclobutane, 3-ethyl azitidine, 2,2-dimethyl thiacyclobutane, 2,2-dimethyl thietane, trans 3,4-dibromo oxacyclopentane, trans 3,4-dibromo tetrahydrofurans, azacyclopentane, pyrrolidine. This is the nomenclature and structure. Now you can see the sulfur 5-member ring, thiacyclopentane, tetrahydrothiophene, 3-methyl oxacyclohexane, 3-methyl ether tetrahydropyranes, azacyclohexane, piperidine, 3-cyclopropyl thiacyclohexane, 3-cyclopropyl tetrahydrothiopyrane. Now you can see the aromatic furan, thiophene, pyridine, quinoline, indoles, adenine. Now preparation of heterocycle or heterocycloalkanes without substitutions. You can see intramolecular accentuation. So if you have the X, CH2N, CH2L, so L is leaving groups and X act as nucleophile and cyclization occurs. That is the intramolecular accentuation. A special reaction for oxacyclopropane you can see with the epoxide and peroxo. You have the 3-member oxygen containing heterocycle. Now 3 and 4-member ring open. How you will open it? So 2-phenyl oxacyclopropane under nucleophilic attack, you will get the 2-methyl 1-phenylethanol. In the same as N-ethyl 2S 3S trans 2,3 dimethyl azacyclopropane, it is ring opening reactions, and you will get the meso NN prime diethyl 2,3-butane diamine. In the same way, oxetane undergo nucleophilic reactions, you will get the N-methyl 3-amino 1-propanol, and this is the usual basic conditions. But recall acidic opening of oxacyclopropane. You can see this is the epoxide ring, primary carbocationic like. So 1-methoxy, 2-methyl, 2-propanol, which is not formed, but 2-methyl, 2-methoxy, 2-methyl, 1-propanol. This is a tertiary carbocationic like. So for ring larger than 4, ring strain driving force is absent. Need a strong acid. Means what? Ring strain. So for ring larger than 4, you can see HBr, it is open. Now again, if you react with the hydrobromic acid, 1, 2, 3, 4 dibromo compound will form. Now for aza heterocycloalkanes, acid just protonate the nitrogen to ammonium salt. Ring opening can be done by Hofmann degradations. Other chemistry is the same as for the acyclic systems. You can see methyl iodide excess, silver oxide, you will get the open ring, and again excess methyl iodide under silver oxide condition, you will get the conjugated system. So now you can see the 6-member ring and 5-member ring reaction at the sulfur. Here reaction has a nitrogen. Nitroso compound attachment on nitrogen, and if it react with hydrogen peroxide, you will get the sulfone, and then sulfur oxide, sulfonoxide, and methyl iodide, methyl sulfur. You know the heterocyclic cyclopentadiene, pyrrole, furan, and thiophene play important role in biological system. The lone pair participate in the aromatic cyclic system, 6-electron system like the cyclopentadienyl anion. Look at here, furan, thiophene. The distribution of 6 pi electrons over 5 atoms makes this system relatively E-rich. E-rich means what? Electron rich compared to benzene. So cyclopentadienyl anion and pyrrole. Now orbital diagram, you can see p orbitals, p orbital furan, and in case of thiophene. So resonance form of pyrrole, you can see 1, 2, 3, 4, 5 relative benzene electron rich system. Now you can see here ppm means what? You have the NMR peak. Now you can see the mass of pyrrole. Now you can see the IR of pyrrole. So synthesis of heterocyclic pentadienes, Paul-Knott synthesis of pyrroles and its derivative and its variations. Variation means you can add different substitution at 2 positions. The cyclization of alpha dicarbonyl compounds to a 1-hetero 2,4-cyclopentadiene. So how you convert diene onto cyclic systems? Reaction with the phosphorus pentoxide. This is the mechanism. You can see minus H plus, and then again H plus on oxygens, and then shifting of pair of electrons in equilibrium, minus H plus, then you will get the OH2. After removing water, you will get this products, and finally you will get the furans. You can see transformations of diketone to furans derivative. Again, transformation of diketone to furan disubstituted products. This is the mechanisms you can see. You can see this reaction is very important, diketone to amine. It gives the N1-methyl 2,5-dimethyl pyrrole, and this is the mechanism goes via enamine. Now, electrophilic aromatic substitution activated attack at carbon 2 is preferred generally. So attack at carbon 2, good yield, but often also attack at 3, you can see here, good. So relative reactivity, benzene less than thiophene, less than furans, and then pyrrole. You can see the mixture of product, 3 nitropyrols, less product, and 2 nitropyrrole. The same is 64% yield in case of 2 chlorofurans. And you can see the 64% yield when react with the acetyl chloride in presence of tin tetrachloride to acetyl 5-methyl thiophene. So basicity of pherols and other heterocyclodienes, relatively normal imines, non-basic lone pair is tied up. Tied up means it is not resonance stabilized. So lone pair is tied up by the resonance. So resonance and protonation occurs on the carbons. So see the protonation of pyrroles. We call this also resonance form or this form. Now pyrrole is quite acidic compared to, the reason is sp2 hybridization of attached carbon and cyclic delocalization of charge. Look at here. Now ring opening. This is the ring opening, means furan ring open, and it gave 2,5 hexadivone and hydrolysis of a furan to gamma dicarbonyl compound. General for all the heterocyclic pentadiene. Mechanism is the reverse of the synthesis. You can see in the reductive desulfurization unique for thiophene. Now Diels-Alder reactions to furan, not general. You can see need a hot dienophile and then you will get the adduct. You also know the benzofusion indole. You can see the resonance form of indole. EAs at carbon 3 allows for resonance forms which do not disturb the benzene ring. Attack at carbon 3 leaves aromaticity, attack at carbon 2 disturb aromaticity. So you should remember this phenomenon is important for competitive exams. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.